All right. Here's the deal. My shirt is very mathematical, and that's why I wore it for you guys. And then I'm probably going to change after this class, because as you can tell, it's too small. I'm going to pit sweat before we even get done in this class. However, it deals exactly with what we talked about yesterday and what we're going to finish talking about today. What is pi saying? Listen to the question I'm asking, Jordan. What is pi saying? Get real. Who can volunteer to tell us why pi is saying get real? Lily?
So it's saying that to the square root of -1, which if it were the square root of positive 1, it would be 1. Because 1 times 1 equals 1. Except for negatives, for any like it has to be two opposite sides of 0 in order for it to equal a negative number. So and like for example, -5 and +5 are two completely different numbers, which means that technically the square root of -1 does not exist.
So, we talked about square roots. Everything you said was brilliant. Thank you very much. We talked about square roots being the edge length of a square. So what Lily is talking us through here is the square root of -1 is what we call a non-real number, because it can't happen, except it can, just in a whole different branch of mathematics.
It says error.
If you try to do it in your calculator, when your calculator is not programmed the right way, you got to change how your calculator's thinking, it will tell you it's an error. This is what we have decided, and I take great opposition with this, is the mathematical number I, which just means square root of -1, which is the imaginary, not real, number. Now, what is I saying to pi? Be rational. And I'd assume like a dude or a bro or a man after that, right? Like, be rational, man. Be rational. So, because pi, we said, is irrational. So going back to our conversation about rationals and irrationals, what is the root word of rational numbers? What is the root? Ratio.
Really?
Yeah.
I thought
So rational numbers. Ratio. It is ratio. So a ratio means a comparison between two numbers. Pi, like we talked about yesterday on Pi Day, cannot be written that way. The closest, until we get into really big numbers, the closest fraction approximation, so I'm going to use squiggly equals. If anyone know, especially if you came to our Pi Day lunch.
Oh, it's 7.
Spencer? 22/7 is the nicest one that we use. And that gets us 3.14, but then it falls apart. So this is close. And there's another one that uses hundreds, right? Like much bigger numbers. But this is the closest we can get, but that's not accurate. And math is all about being accurate, being actually correct. So if you are currently doing something else, like your own work, or playing with Rubik's Cube, or doodling, or something that has gotten by until now, stop, get out graph paper, let's do math. Groovy paper. I want you and your group, keep this up, but we're not looking at this right now. If you're working on your homework right now, stop. You should be looking at graph paper. Groovy paper. If you need 925, raise your hand. I'll come around and bring it to you. If you need 925. No, we'll go over that tomorrow because I felt like we didn't finish the lesson yesterday. Do you need 925? No. Hey, Nolan asked a great question. I'm not going to go over 924 today because I feel like we didn't get that finished.
922.
We did that last week.
I don't think we did that.
Unless I'm crazy. Anyone need 925?
Yeah, no.
Alright, so we might not get as far as I had planned. If anyone else needs 925, just come up and grab it. Let's go ahead and take questions on 922 and 923. Yeah, I mean, I guess you guys were right. The last one I had pulled up was 921, so. Alright, 922. And then hopefully we'll... Actually, this is great because I didn't get to finish my lunch yet. So while you guys check answers, I'm going to eat. And if you have a question, I might see if a classmate can help you out. I have 4 shrimpies to finish.
Wait, I have a question. Oh, for 975, I thought it was just those numbers, not the squared numbers. Because I did 8, 9, 17. That makes a right triangle. But if you square them, there's not.
So I did not get your grade last night either. My wife and I have been busy with some stuff. So if you turned something yesterday, I still have it. It's just over here in my folder. So I saw people looking at the bin. If you're wondering, do I have it? You guys probably come ask me and see me at some point. Questions on 922?
I'm looking if I see those.
Grant, I have your 922. I think that's the only 922 that I have in my folder right now. So Grant, do you want it back to check it, or are you pretty confident?
I want it back just to check it
One more time. We're gonna celebrate. Alright, I'll zoom in a bit more because I realize this one doesn't have. Probably not. We got too much to do today. Yesterday was our one pivot from the regular. So guys, my concern, and it's not that big of a concern, but my concern is the longer we take to check homework, the less we get to cover the lesson and practice things. And my goal is that we're doing closure by Friday. If that can't happen, that's okay. But like, that was my goal, to squeeze everything in before the test. I will still make it happen. But if we don't have any questions, I'm going to move on pretty quickly because this is recorded. You can go back and check the answers later. Brenda?
79B.
Yeah, I was just gonna say that. Not good too.
Yeah, I got 103.
I got 103 too.
I don't know
It's the
what
exact same thing as A though.
I thought that was 103.
Yeah, I got 103.
I got 5,003.
Hey friends, you're all acting like this is a big dramatic thing, and I get it. It's like the 12-year-old brain, but over and over repeating what you got does not help anything. All it does is distract my brain and make things more difficult while I get this out. So, why do you think their answer key was showing 46 and 90 added up? Because it was still answering part A. Notice how this is identical to this?
Oh.
Someone making the answer key done did goof. So, no, this is not from me. This is from CPM, man. This is, if I zoom out and like show this is 56 pages of answers, straight up PDF format. This is from CPM. So somebody done did goofed. B's answer is just missing. So yeah, you guys who were shouting, I got 103, I got 103, did you get 103? I got 103. It's 103. You're fine.
Mr. Arthur, you sound like
Nothing to freak out about.
I see 100, I see 100, I see 200, 200, I see 200.
You mean an auctioneer?
Yeah. My grandpa
So, we're going to move on. This angle would be corresponding with X. It would be 103. Moving on. Other questions. Lily. Jake, rein it in.
So, when I add together 8 squared and 15 squared,
What'd you get for 8 squared?
64,
What'd you get for 15 squared?
calculator,
It's 225, right? I think. Which problem are you actually talking about? Because I'm not sure what we're looking at. 75. Hey, if you're talking, you are not helping, and quite frankly, you're being disrespectful to, like, me and your classmates. Said 75? 8, 9, 15, and 17. Which 3 lengths should she use to make a right triangle?
Oh, wait, no, I realized. Oh.
So remember, to make a right triangle, we will need the short leg squared plus the other short leg squared to equal the longest leg squared. Because the hypotenuse will always be the longest leg.
I was multiplying, not adding.
Ah.
I did it wrong.
Alright, so we found the brain goof there.
Yep.
Other questions?
We checked 923.
We are going to check 923. Because both of them should really be done by now.
Oh my god, when you get to chapter 10, so it's so weird.
Hey, if your homework's not done, please don't lie to your parents about it. I've busted out so many kids recently that are lying to their parents, and all that does is make your parents mad at you and you lose your Xbox or whatever. So please stop lying to your parents.
Excuse me, can I please have Stella Burkhart to the office? Stella?
923.
Barnhart, I'm sorry, Barnhart to the office. Thank you.
We're into the tougher diamond problems now, where we're involving decimal values.
The only thing I have trouble on is remembering like what to do with them. I don't have any other thing that's bad. Like just like remembering like, oh yeah, I gotta do that.
Oh, there wasn't 90.
Product is always on top, sum is always on bottom.
It never clicks for me.
I keep forgetting we skipped question 92.
923 answers will be in the video. Ask now or forever hold your peace, at least until you come and see me privately. I don't know. I was trying to make it sound like that old expression, but I lost it. So. Speak now or forever hold your peace. It's like from court or something. It's not Yoda. Yeah, I got a bajillion of those. Those are not mine.
No, these are mine. Can I replace this?
Sure, I don't care. The boards were empty when we first put them up, and I was like, this feels weird. I'm going to put something on here.
Oh, too bad 992 wasn't in there.
All right, any last questions? I have 1 shrimp left. So, while I finish this lonely shrimp, you and your team discuss which of these numbers are irrational. Checking answers shouldn't take very long, and you can go back and use the YouTube video, but like, I only got 20-ish minutes left. What? I don't give a crap about my YouTube channel, but I do care that I'm losing class time. Talk with your teams which of these numbers are irrational and why. We will do random cards to talk about these. I'm going to make it a little bigger.
Fractions are always rational. 1 square root 4 is not rational. All fractions are not rational. Patrick, no calculator.
Oh, no calculators.
Yeah, no calculator.
Every table just had one person being a calculator.
Is 7 rational? Wait, why'd you make it dead?
Square root of 7.
Oh.
It doesn't make it
Big
square.
brain.
For a nice square. Yeah.
At this point, I don't see the time. And we're like, that's not really what we do with our own thing. I've got stuff. Have you seen that class? Yeah, we don't have much school left, honestly. Rational, as we talked about yesterday in your videos or the lesson or whatever. Max, am I boring you? It hurts my feelings when you put your head down. Can be written as, and not that it has to be written as, but can be written as P over Q, or we said A over B, right? P and Q, yeah, that's cursive Q. You guys don't know cursive. That's like halfway cursive and halfway print because I've never my brain has not made the switch back and forth. So P over Q, A over B, whatever. Keep your judgment to yourself, Miss Sarkozy. So, can we write each of these numbers as a fraction? Is essentially what it's asking. So, for -5/9, Jake, what do you think?
Oh, is that rational?
Yeah, is it rational?
Can I do 21/4?
Nope, you can do -5/9.
It is not.
It cannot be written as a fraction,
Oh, yes, it can. It's rational.
even though it's already written as a fraction.
It's rational.
So -5/9 is rational. It's already written as a fraction. But that would be a repeating decimal. So guys, remember, all because a decimal repeats, this would be -0.5 repeating. A repeating decimal is rational. That's what messes a lot of kids up. You should make a note of that on your graph paper, that repeating decimals are rational, because you'll forget that and you'll goof it up on the test. And then you'll say that we never went over this, and I will say, yes, we did, and I will pull up the video, and I will show you, and I'll say, I told you so. And then I'll do this.
Then you should flip us all off, and they're like, I told you so.
No, I normally just...
Mr. Hudson, you're just going to do everything in the video, and then you'll just replay the video when you need to.
Square root of 7. Grant, what are your thoughts about the square root, or we could say radical 7? Did we not talk, seriously, did we not talk about the square root symbol? The other name of it is radical.
No.
So this can be said as the square root of 7 because we talked about a square root is saying if I have a square with area 7, the edge length is square root 7. The other way, because it's quicker to say, is that symbol is also known as the radical symbol. And sometimes it's abbreviated by, hey guys, we got too much conversation today. I'm going to shut the door and hope that it helps. But if you can't handle class, go somewhere else. You can go to your advisor's classroom and explain to them that you aren't mature enough to be in a 7th grade math class today. Really, 8th grade, honestly. You can go to the office and call your parents and tell them you can't do school today. Or you can decide you're a mature young adult and you know when it's appropriate to talk or not. So Grant, sorry some of your classmates were being disrespectful. What's your gut say about square root of 7? Reminder, you guys are always allowed to pass when I'm using random cards and putting you on the spot.
I think this might be rational.
So we talked yesterday about square roots that become rational or not. Do you remember? And it was pretty bold. We talked about certain roots are perfect. I don't like using that word, but it's literally a math word we use. And other roots are non-perfect. Can you tell me whether this would be a perfect root or not? It's all good if you can't. That means I'll just move on to the next card. You're right. It's not perfect. Do you remember why? If I make a square that's like 2 by 2, what's the area of it? If I make a square that's 3 by 3, what's the area of it?
9.
So 7 is somewhere in between the 2 squared and the 3 squared. So Max, do you want to jump in and help us out with... So Grant already said he believes it's a non-perfect square. It's between 2 perfect squares. Do you think that could be written as a fraction?
I mean, 7 is never really a nice number, so I don't think so.
That's a good gut instinct. The 7 is often like a not great number. This is not rational. If we put that in your calculator, it would look like it stops, but that's only because your calculator runs out of space. Non-perfect squares. Not rational. Are you trying to do the next one? Because I got cards. This is still 924. So we're finishing 924 and we'll get into 925. Because we're still talking about rational, irrational. I mean, we can squiggly line if we ever get to doing 925 stuff. Nolan, 21/4. What do you think?
Rational because it's a fraction.
Sorry, I missed the first word you said. Rational.
Fraction.
For a second, I got scared. You said ear in front of the word rational. It is rational. It's already a fraction. That one's kind of like a gimme. Patrick, what do you think? Where did Patrick seat himself today? Patrick, what do you think about square or not square root negative 50? Ooh, good moment. Sorry, I know I'm talking over asking you a question. This is different than if the negative is on the inside. Okay? This is not imaginary. This is real. This is a number that we can deal with. But do you think it's rational or irrational?
I have no idea, so I'm going to make a guess. It's irrational.
Why'd you guess that?
Because the negative's on the outside and it just doesn't look right.
The negative has nothing to do with it. Can I ask you one more question? Is radical 15 a perfect square? Would it be like 3 times 3 or 4 times 4 or 5 times 5? No. So this is a non-perfect square. So our gut is telling us it's probably irrational because it's a
And it's correct.
non-perfect square.
Also, the negative is like basically a negative 2.
At the end of the problem, we apply the negative. It doesn't change whether we're rational or not.
Yeah.
Right? I can have negative fractions. That's fine. Nevin, what do you think about pi squared?
It seems irrational
Why do you think it seems irrational?
because pi is already irrational.
Yeah, so if I take an irrational number and
multiply by
square it, well, I don't know. We should probably talk about some examples before we try to make a blanket rule. But Nevin knows pi's like, oh, I remember where it is. Parkour. I have a lot of digits of pi. I know, pi's endless until you rip it. So pi, right, pi keeps going. It keeps going. So I just need to hang this up. And then if dot 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 on the end because it keeps going forever. There's a lot of, there are hundreds of, it's stuck to itself is the problem.
That's a lot of pie.
This is a lot of pie.
I don't know if I
All right.
Patrick, you know how
Alright, we should keep moving on this. Let's just leave this laid on the ground.
Yay!
Just lay it down. Sweet. I'm gonna hang that up later probably. Alright.
We can hang it all the way around the room.
Right. Brenda. Negative square root 76. Refocus. What? Yeah, what's 7 times 7? What's 8 times 8? 64. What's 9 times 9? We jumped past. So what do you think? Irrational, probably. What about Gust? 730/99. But again, this would repeat as a decimal, right? It would repeat as a decimal. No. Over 99, the repetition rules get weird. So we can come back to
Somewhere
that.
99, I think I remember from that book where I think that makes it just like it's the same as dividing. It's like moving the decimal point over to the left.
So throw it in a calculator if you want to double check what it comes out to, and we can remember the rules that way. But we got to keep moving, so I'm running out of time quickly. And a number in scientific notation. Maddie, what do you think? Would this be rational or irrational? I could not hear you. Rational, so like you get to check, not next. Guys, this turns into negative 0.064. How do I read that the right way? It's 64 thousandths. So would 64 thousandths be a rational number? Yes, it's a fraction.
Here's the thousandths. It's because the first one is 10,
Tenths,
then
hundredths,
then thousands.
Thousands. All right, moving on.
Mr. Hudson.
Yes, everybody calling my name. Hey, look, a hand.
Not all fractions are rational.
not all fractions are ratios. Well, that doesn't really count. That's like where you break the rules. Because anything over 1 doesn't really technically count. It doesn't do anything. But so, what you're discussing is what we call a complex fraction. What I'm discussing are regular fractions we deal with where we have an integer over an integer. So I love what you're saying. I really do. But you're breaking the rule of when we talk about a fraction. We're talking about an integer, a number. Not an endless, non-repeating, non-terminating. That is not an integer. These, guys, I got to make sure we actually heard this yesterday. This is integers. So entire value, positive or negative, doesn't matter. But integer over integer. You're breaking you're not using integer. So what you're saying doesn't count. It's not an integer. Pi is not an integer. Integers do not use decimals or fractions. Integers are entire numbers. Positive or negative, but entire. No partials. What do we think about these numbers? Take 60 seconds to talk with your team. Which of these numbers would be irrational? Wow, wait till let's talk about who dies at the end of the movie. Yeah. Because that's what the company or the if I wanted to order this again, I could search up a piece of pie. Because you can never have all of pie. You can't get to the end.
Oh, also,
Mr. Hudson, we just grabbed the whole word pie, and still say we haven't gotten to the end.
Did I notice what?
remember where it says no pie equals 0.
Yeah.
Notice that it has pie on it.
Yeah.
Yeah, that's a pie.
Alright.
Alright, we should just wrap the whole room pie and still say that we don't have enough pie.
This takes up like an entire wall. I thought about putting it on the window thing.
I know how to solve rule 2. Just take the decimal point of the 26.
All right, Aiden. Hey, bring it back. I said 60 seconds and I meant it. We got to keep moving. Aiden, which of these is irrational?
None of them.
What do you mean?
None of them. They don't have any, even if they were repeating, they wouldn't be irrational. All of these, they're not integers, but they can be written as fractions.
Okay, Jordan, what do you want to chime in with?
Decimals are fractions.
We say what? Decimals are fractions.
Yeah, just written in a different way.
Squares are rectangles.
Just written in a different way.
Without the slash. Or the dot.
Now be careful. Not all decimals. All terminating decimals.
We're terminating decimals.
They stop.
So,
They do not keep going, right? If it terminates, it stops. The Terminator stops your life. Right? Like Arnold Schwarzenegger, the Terminator. Like the robot that came back from the page. He's watching over the classroom by the fire alarm.
Where?
He's right by the fire alarm. The little flashy box thing.
Where?
Terminator. Arnold. That's what the Terminator says. All terminating decimals.
See, I've never watched Terminator, so I can't.
You probably shouldn't because it's rated R. A lot of people get shot in
I've
mutilated.
watched that.
All terminating decimals are rational. Now here's the other thing. What other type of decimals are always rational? Spencer? All repeating. So all terminating decimals are rational and all repeating.
Isn't that all decimals?
No.
Pi is a decimal.
So take pi, for example. It does not terminate. It does not repeat. It just keeps going with no pattern.
How do
We can we can look. There is no pattern
Well,
in
then how
pi.
do we figure out the next digit?
Jake,
It's a division. It's a constant long division.
Jake,
It is literally like always performing. So take a really big perfect circle, measure the distance around, measure the distance across. That long division will never end.
So a computer right now.
I know, but how do they figure out?
Yeah, they have figured out over 2 quadrillion places. Probably I don't know if we've gotten to 3 quadrillion yet. But way more decimal places than we care about. Please stop just shouting things out. Jake.
Can you have a decimal on a fraction like 0.3 over
Yeah.
1?
But that's called a complex fraction. That does not count as P over Q form. Like how we talked about in the last. If you put a decimal number or a fraction into a fraction, it is now called a complex fraction.
So can I do that like on my homework? Like if I want to simplify so much that I just.
I mean, you can. It's not like bad. Like putting decimals or fractions into a fraction, it just makes it kind of complicated.
Okay, yeah.
I mean, so do you remember keep, change, flip?
Yeah.
That is dividing by a fraction. That is, if we set it up in fraction form, a lot of times it was a fraction divided by another fraction. It's a complex fraction, but most of the time we write it out so it doesn't look so complicated. Does that make sense?
You should get a poster with like
I should get a poster?
100,000 digits of pi. It's like little numbers.
Yeah, I need to spend my classroom budget on more stuff like that, but I don't think I'm missing posters, right? I'm kind of out of wall space these days. So we need to make our own.
Look, you have blank space right there.
So, here's why. Let's remind ourselves why repeating decimals also work. We talked way earlier in the year, but you're probably going to remember this for the state test. 0.57 can be written as 57 hundredths. As Brenda reminded us, the first decimal place is tenths, second is hundredths, and we keep going. There's your reference over there if you need. Yeah, Patrick's like, I stare at that all the time. But as soon as I tell it to have the repetend, remember this symbol is called the repetend. Also, we call it the repeating bar.
That'd be 57.
Well, I don't like that. I really don't like that.
Hey, I do have things to teach you. The dot, 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 known as an ellipse, has 2 purposes. The one purpose, like we use here, says this keeps going like what you see. So 57, 57, 57, 57. It's going to keep doing the thing we see. However, dot, 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 in a situation like on pi, says this keeps going like you see. And do we see any pattern? No. So this keeps going with no pattern. It's not random because they're doing a division to get there. Because we said pi is circumference divided by diameter, but it keeps going. So guys, this, careful, this does not mean, oh yeah, it's rational. Only if it is a repeating decimal number. Now, if we are repeating 2 digits, can anyone remember how we make that happen? Brenda? What if it was just repeating a single digit? Do you want to go ahead and pass for now? Yeah. Anna? Yes. However many digits we want to repeat, that is how many 9s we put on bottom. However, if I instead say like 57 over 999, now this wants to repeat. This is not equal. I'm setting up a different problem. This wants to repeat 3 digits. How do I turn 57 into 3 digits? Brenda, save yourself. Or redeem yourself. Over here? Oh yeah, it does.
Add 0 behind it.
Lily? A 0. So is 057 the same as 57? Yeah, because there's no hundreds. But then this would repeat 0.057, 057, 057. Which it doesn't sound great, but guys, that is fine. That is still a rational number, right? So any repeating decimal. Now you can do this on your own, but also division by 11 and division by 7. We looked at all those earlier in there. Division by 9, 7, or 11. Repeat. Connor? It's not. It's not. We've proven it does not repeat. You can dig into that on your own if you want. We don't have time to dig deep into pi. Anyways, I forgot my fork. So, if we had something like 1 over 999, is this rational? You're like, yes, duh, Hudson, it's already a fraction. But what does it become as a decimal? We would put 2 zeros in front of it. It would be 0.001, 001, 001, repeated forever. And now it sounds like we're trying to sing in binary. Yo, we will probably come back to this. We will probably come back to this after the state test. This is actually a pretty fun proof of how we, like, hey, I got 5 minutes. If you're packing up, like, unless you want to stay here longer or get here earlier, you are not stealing 5 minutes from me. Absolutely not. This is a really fun proof of how we actually say, like, this is why division by 99 creates repeating decimals, but we don't really have time to dig into that right now. All we need to remember is any division by 9s, any amount of 9s, unless it cleans up nicely, like if it reduces, like say you had 999 over 99. Like, okay, so that's not what we're talking about. But any division by 9s will repeat and is a rational number. Anna. Denominators of 7, 9, or 11. Yep, all make repeating. Nine's the nicest because it repeats the numbers in the numerator. If we divide by 7 or divide by 11, it does not repeat the numbers in the numerator. It repeats other stuff. Division by 7, I don't know if we dug into this or not. Math 7 does, so you should have dug into it last year. So maybe we'll come back and do a quick lesson on this before the state test. Yeah, I know, but that doesn't mean that your teacher should have not taught you. So I'm going to blow your mind here for a second, and then apparently I'm just not going to get through the lesson. 1, 4, 2, 8, 5, 7, 1, 4, 2. That 9 is a lie. 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. 4, 2, 8, 5, 7, 1, 4, 2, 8. That 6 is a lie. 5, 7, 1, 4, 2, 8, 5, 7, 1, 4. 7, 1, 4, 2, 8, 5, 7, 1, 4. That 3 is a lie. The digits that repeat in the 7s are the same digits, 1, 4, 2, 8, 5, 7, starting from a different spot every time. So 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. Like, especially if you put these in a calculator, that will give you more digits. Up until, obviously, 7 sevenths is not going to repeat. Let's not play that middle school game. But you said every division by 7, didn't you? Any number divided by itself. All right, so hold up. Write these in fraction form real quick. Test yourself. Write these in fraction form real fast. Show that they are rational numbers.
Shut up, Connor, please.
All right, well, Connor just gave away his question. So, Connor, we'll wait till you get your notes back out since you decided you were going to be the only one to not do class right now. So, Connor already shouted out A for us. It repeats 2 digits. So I put it over 2 nines. How many digits it repeats?
I like how we learned like a really cool trick to use.
Yeah. Is what? Is 88 over 99 the same as 8 ninths? Well, is 0.8 repeating the same as 0.88 repeating? Yeah, it is. 0.8 repeating is the same as 0.88 repeat. It repeats eights forever.
Oh, yeah. Oh.
So, Walter, you want to help me out with B? Yeah, 999. C, Spencer. How many nines do I want on bottom? Yeah, Spencer, you threw your voice there. I think you should become a ventriloquist. And then, like we already wrote down, already talked about 8 repeating. Could be 8 ninths, or you can do 88 over 99, or 888 over 999, or 8,888. All right, get out of here. Have a good day, guys.
Oh!
Jake, unnecessary.
That was unnecessary.
The 9-9 rule is really sad.
Yeah, but I'm in charge, so I get to make those decisions.
Wait, Mr. Hudson makes
And actually, it wasn't unnecessary. If we want to actually argue that, if you didn't know that beforehand and you weren't paying attention,
What would I have done?
just asked me,
I asked.
it's worth, or when Jordan or whoever asked me, it's worth discussing equivalent forms. It is not unnecessary. Okay, come to my desk. I gotta get this off the floor so people don't step on pie.
Mr. Hudson, pie is like a speeding train with no brakes in many ways. It doesn't ever end.
And it never, unlike whatever that TV show is, it never loops, it never repeats itself.
Thank you.
You are welcome. So, are you feeling like fruit snacks, granola bar?
That is very creepy.